additional part of that. So we talk about what is a MapReduce program, and we have seen the test program, which is a word count. Then right now we know how it works. Then the next thing is, in addition to mapper and reducer, MapReducer framework provide additional part that include also we have seen the MR unit for testing purpose. Okay. Then today you will practice in the exercise lab, right? The MR unit, and also in addition to that, we are going to today discuss about the combiner as well as the partitioner. So because the reducer itself sometimes the bottleneck of the processing, so how to reduce the workload of the reducer using the combiner. Then followed by the partitioner to specify the specific group of the reducer for the output of the mapper. We will see what are they. And also I add the new material, that is the MapReducer 7, that shows some typical types of MapReduce programming. The word count is a summation. So summation is not the only functionality for the MapReduce program. We can use the MapReduce program for indexing. We can use the MapReduce program searching. We can use the MapReduce program sorting the data. Also, we can use the MapReduce program for join operation. Join means that from the two data sets, we will combine two different data sets. So we will see not details of the programming itself, so just the overview how we can design the MapReduce program. And also, I'm not going to have a lecture, but I will show you. It's already uploaded class website. It's some types of little bit more details of the different types of the MapReduce program. So you can refer. You can use the slide when you develop your MapReduce program in your project. Okay. So summation is not the only the type of MapReduce program. There are a variety of the MapReduce programming, so it can be helpful to design your program in your project. Okay, so so this is the overall overview of how MapReduce program is working. Okay, for example, from this is the Hadoop data block. So usually 64 megabyte or 128 megabyte. So as we have learned before, the Hadoop has the locality. Locality means for each block we have one mapper. Okay. So the mapper is controlled by the task tracker. So task tracker will execute one mapper for each block. That is based on the first input format. So from the file, so that block has the file. From the file, record by record, we read the data. Then the mapper will process such a record by record to get what? Key and value. So in case of word count, the first key and value pair is what? Offset, comma, record. One line of data. Then you can apply regular expression. Also, you can apply the generic function provided by your programming, Java programming, to extract the specific value of the data. Then not only just one pair of the key and value, actually the most important and most of the part of your MapReduce programming is such a designing key and value. How to emit, how to extract key and value pair from the mapper and reducer. That is the mode. Then, depending on the type of the data, you can decide, you can match the object or type of your mapper and reducer. That is the overview and most important part. So mapper will extract a huge number of key and value. That will be, so forget about combiner and partitioner yet, and that will be shuffle and sort. That is what? That is intermediate form. Then it can be transfer. Transfer means it will use the network, then move to the another node in the Hadoop cluster where reducer is working. So reducer is what? It combine all the intermediate data, then group by what? Key value. Same key, then you can add. If your program MapReduce program is a summation, you can sum. If your program MapReduce program is average, you can average just for the same key. Okay? Not only just one, sometimes you can have many reducer. Then question. First question is how to, in case when we have one reducer, it's not a problem. So we can send all the data from mapper, key and value to the one reducer. What if we have two reducer? What if we have the many reducer? We need to divide, right? We need to have the, for example, I have a 4 reducer. One is a summation of spring season. Another one is fall season, the summer, fall and winter, for each season. How can we divide? Using the key value partitioner will partition your map, the key value pair from the mapper to specific reducer. That is the main job of the partition. That is a partitioner that we are going to discuss later. And also, you can realize how, suppose that we have 100 mapper, okay, 100 block. That's usually happen if you have the file size 1 petabyte. How many blocks? So many blocks. But each block has their own mapper. So there are 1,000, sometimes 10,000 mapper. Will send all the data to one reducer. Suppose that we have one reducer, which is default. So if we do not specify, it will be one reducer. It's a bottleneck, right? It's a huge trend, the network, the bandwidth. And also, reducer will be very busy to sum up the millions, tons of billions of data. Okay? So, usually, if you use the default setting, the reducer will be bottleneck, the weakest point in terms of performance. To address that problem, what if we do not have the whiteboard? What if we have the data that can be combined earlier? Like instead of sending the, think about the word count. You already learn and practice the word count. So for each word we have array of the data 1 1 1 1. So for example the 1 1 1 1 1 instead of the 1,000 of 1 1 1 1, why don't you 1,000 sum up earlier in the combiner? Okay, then we can reduce the network size. Also, we can reduce the overhead of reducer. That's the idea. So that is a combiner. And do the same thing here, do the same thing here. So that's the reason it's called the combine earlier. So summation is the okay. So we can sum of the part of the data earlier, then send the data, finally reduces. Can we use the combiner always? What can be the counter example of using combiner? When we cannot use the combiner? Think about average. Okay? So average. So for example, I need to use this one. This is a common mistake during your elementary school first time when you learn the average. Okay, so So what is the average of this one? So this is the 3, definitely 3. Then what about this way? So first average 1 and 2. What is this? It's a 1.5. What is the average of the 3, 4, 5? It's a 4. So then why don't we average these two? Is it 3? It's not 3. It's probably 5.5. So divide by 2, 2.7. So 7? 7.5. So they are different, right? So as you can see, so Heng-Shen, can you find the whiteboard in the lab? So if we apply the average to the combiner, and output will be different from the correct value. So not always we can use the combiner, only specific function. That's called the associative and commutative function. Okay. What about the maximum? Maximum can be used, right? Maximum, even though you partially find the maximize the local maximum value, eventually we try to find the maximum value. So maximum value, the minimum value you can use. However, the standard deviation or such average cannot be used. It's the same thing when you design when you make the MapReduce program. So you need to decide whether I can use the combiner or not, depending on your algorithm. Okay, so we will see the more details of the combiner and reducer. So this slide shows the how combiner is working using the very well-known word count example. So this is a typical word count example. Excuse me. There are two nodes. Okay, we have the two blocks like this one. So output of mapper is the key and value, as we have seen before. First key and value is the offset and the line. Usually, most of the time, because our input of the head cluster is what? It's a document, right? Log data or transaction data, mostly such a data file. So that file includes the bunch of lines. Okay, so that is the reason offset, but we are not very interested in the offset, so we try to emit, which means extract the value that we are interested in. Okay? Then finally we can have the one, cat one, so on. So then it will be shuffle and sort, then send to the reducer. This is our final output. Instead of the external, it's much smaller. Very cute. So instead, we perform the summation. Summation is our main algorithm. Okay. Sometimes even such a simple algorithm to provide the huge insight of the data. But in your project, you need to think about what kind of algorithm you are going to use. I'm not asking you the brand new algorithm, but mostly the statistical function or some well-known type of MapReduce program like the indexing or inverted indexing or term frequency that we are going to see. Sometimes you can do the join. Even join operation is not easy in the MapReduce programming because join is not our main focus. Join needs a lot of the temporary space in the memory and a lot of I/O. But sometimes you need to do that. Okay. So anyway, so this is a word count. So idea is why don't we perform such a main algorithm earlier before we send transmit the data, intermediate data. That's the combiner. So combine in this case the cassette or there are two types of so we can sum. And similarly we can combine the and the here. So two of so comma key and value. Think about this combiner, what's the main difference? This combiner and reducer.
Combiner works for a single reading or
No difference actually. It's the same summation, right? So most of time, you don't have to develop a new algorithm for the combiner. You can just use the reducer. So sometimes you need to change a little bit the key and value, but most of the time you can still use the same class even you don't have to code. You can just use the reducer class. So in your driver, you specify what is the mapper class, what is the reducer class, right? Do you remember the dot, the mapper and reducer class? You can specify the same name of class for the combiner most of the time. Okay? But that should work satisfied with the condition. Okay? So combiner basically same as your reducer. So it has the key and intermediate key. So this is actually, if we replace this is a reducer. This is actually used for the combiner. So key and array, iteration of the value. Then using your algorithm, you can get the result key and result value. In case of word count, it's a summation. So this is a reducer and combiner. So you don't have to develop the new combiner. Okay. So how can we specify? So in your driver, draw dot set combiner class. Then this sum reducer class is exactly the same as your reducer. So you can still use. Then compare what is the overall performance. You can see the better. Okay. Also, that combiner you can run just one time, or you can run depending on your algorithm. You can run several times. In case of summation, just one time is okay. But if you have the more complicated algorithm in the reducer, it can be run many times. But don't forget whether this is the associative and the commutative algorithm. Commutative means you can different order of the data, but output is the same, which means A plus B plus C. You can do the A plus B first, then plus C, or B plus C first, then A plus A. So that is the commutative. That should be okay. Okay. So combiner itself is not a big deal. You can practice in your exercise lab. Okay. And just put the display. This is just when you give for example, how many mappers are you running in your map reduce programming? It depends on a number of blocks, right? So if you give the local variable only, like for example, some parameter value, so in your code, in the static mapper, if you provide such a parameter value, it will affect only the mapper. So instead, if you need to set up, if you need to provide something parameter value, it should be the common to the all mapper. How can the all mapper share such a data using context setup and context? Then that will use the RMI, the communication in Java virtual machine. So using the Java virtual machine, you don't have to worry about that. Using RMI, the multiple class, okay, can communicate each other, which means you can share such a parameter value. Okay, so do not code directly such a value as the local variable. Instead, you can use such a configuration. Okay, that's the main part of this one. Then partitioner. So I'd like to have when you learn the map reduce program, final output will be HDFS file. Okay, you already see the result is the HDFS file. So I'd like to get the something value grouped by the season or weekday, or even it's too big file. So I'd like to separate such a file. Output file not always a small, it can be bigger than original file. So I'd like to distribute or along the HDFS. So to do that, so we can use the partition. Partition give the condition. Okay, condition for each the intermediate pair of the key and value where this pair the transfer to the each reducer will take this one. So this is kind of the condition you need to provide. For example, we have the transaction database file, huge file. That transaction, I'd like to see how many transactions per season. So your key is starting from the offset and line. Then from the line, you need to extract the date of the transaction. So date and the other value, you can use the one if you just want to count. Then from the date, so you need to decide the which season is that. Or even if you want to output as the date itself, you can still leave there. Then apply the condition. The March through April, June. March, June is the spring. So spring is the first reducer. And July, August, and September goes the second reducer. Okay? And October, November, September, October, November. What is the fourth season? Nowadays it's not the, anyway, the October, November is the fourth season. It's a reducer 3 and the other reducer 4. So you need to implement that condition, then specify the reduce specific reducer. Then output of the first reducer is the file only include transaction in spring. So you don't have to the post processing to get the transaction information about the specific season. So how it works? So that is this one. Then oversee the example. This is a typical word count example. We use the one reducer, but what if we have the two reducer? So in partition should divide using the algorithm in this case on I cannot find any specific. Anyway, so this is on the is the first partition and the other the second partition or something like that. Also, to just evenly distribute the data, you can apply hash function. So which is called the hash partition. It can evenly distribute the file. At the time, there's no algorithm, just evenly distribute the file. Then each reducer will take care of the specific partition. This is the default partitioner. Default partitioner is the hash partition, which means do not apply the specific condition. Instead, it's just evenly distribute the data. Okay, so which means it's a key hash code. Then the data key and value will be the distributed. The problem is what is the optimal number of the reducer? Okay, there is no general answer. Best way is you need to test. Okay, do you think the more reducer is the better? I don't think so, because if you have a lot of reducer, it will be more complicated in network transaction. So one is definitely bottleneck, and too many is too much complicated. So you need to find the optimized one. Best way is you can test with a smaller size and then try to find the best one. Okay. So these are the example of the map reduce program that can use such a partition. Like the key will be weekday, the per day of the week. For each day of the week, we have the something transaction log data. So at that time, we can have the 7, the reducer. Okay. This slide shows how to create the custom partition, not hash partition. Okay, so you need to specify your own algorithm here, the get partition and your you can specify the 0 to number of your reducer. For each, you need to specify the condition. Okay, so for example, the weekday, if you extract the weekday, in case of Monday, you assign the 0, then it will go to the 0, the reducer 0, first reducer, and similarly Tuesday, the 1, and something like that. Kind of a case, the function used in any program. So you can test the partition. When you see the example of the partitioner, then you can use them. The others are the additional functionality provided by the MapReduce programming. So first one is when we access the HDFS file, we use HDFS, Hadoop HDFS, the command, right? So, or we can use the Hadoop command to execute the MapReduce, the jar file. So what if I want to directly access the HDFS file from my MapReduce program? Yes, you can do that. So MapReduce provides API to directly access the HDFS file. So sometimes you need to do that. So that is this one. So using the file system FS, so you can actually directly access the file. It's similar as well. When you access the file using Java programming, so you can define the file stream and define the path, same idea. So you can access the HDFS file in your MapReduce programming. So at the time, when do you need? For example, I have an info file, so I specify the out file. What about I try to merge the join? I have a lookup table. The code table. 0 means the Monday, 1 means the Tuesday, 2 means Wednesday, something like that. So you have such a table. So at that time you can directly read the data file, okay, from HDFS. Then you can merge it or whatever. These are the API provided to handle the file system. It's the HDFS file system, not the local file system. Okay, how can you handle the local file system? It's just pure the Java program. Okay. So, for example, in this case, it's a list of the file. So directory listing. Okay. So under the path, under path, so all file list will be displayed in this example. Okay. And also you can write the data using the write method. Okay. Sometimes you need to work with, so we have the HDFS. The file, input file will be used for the input string. So you can get the data from input data from the HDFS. What if I have the lookup table? This is the table, and the 0 is a Monday, and 1 is the Tuesday, and 2 is the Wednesday, and so on. This is on the file, okay? Or your parameter value. Then how can we set up? At that time, you can use the distributed cache. Why? Because this lookup table, this file, is not only one mapper. It should be accessible by all the mapper, right? All the mapper in your system. So at the time you can use the distributed cache. Okay? This distributed cache it's actually based on the RMI protocol used in the Java. So it can be accessible throughout the whole the Java virtual machine. So for example, you can define the configuration. It's the same as the setup method when we see the before. So distributed cache, add cache file. So then if you define this one in your the driver code, it can be accessible by all the mapper. Okay. Then you need to specify in your when you execute the Hadoop command, Hadoop jar command, you need to provide all the file list. Then it can be accessible. This is a reusable classes, which means it's built-in classes. The new API provides that one. I never used such a thing, but it is possible. For example, inverse mapper. If you wanna swap the key and value, so you can use the built-in, the function or the classes for specific purpose. Okay. However, until you practice by yourself, understanding the concept itself is too easy. But after the class, nobody remembers such a thing because it's a programming issue, programming topic. So you should code by yourself and compile by yourself, see what's going on. Otherwise, it's not easy to understand. Nobody actually learn the new program language by memorizing all the syntax or textbook, right? So you need to do it by yourself. Otherwise, it's just just concept only. So there are some practical tips that if you know just a tip, it will be better or helpful for your programming. So we will see some of that. Okay. Debugging in MapReduce programming, it's not easy, okay? Because in case of the word count, definitely it's a hello world. So there are not much you can do in the programming. So debugging itself is very easy. But in real life example, sometimes it requires the 10, 20 set of MapReduce programming. Also in one mapper, there are a lot of steps to extract, to